Hi viewers, welcome to Vidya Peter. This is Nageshwari from RMK College of Engineering and Technology. In this video, I am going to explain about the problem related to RL series transient in a simple way. So, the problem is, find the current in the circuit shown in the figure. At an instant t, after opening the switch, if a current of 1 amps had been passing through the circuit at the instant of opening. So that means, this is the given circuit. So this is the given circuit. So in this circuit, they asked you to find the current. So after opening the switch, if the switch is closed, then the current flow between 12 volt, 6 ohms and 5 Henry, right? Okay. If the switch is closed, the current flow is between 12 volt to 6 ohms and 5 Henry. So this 24 volt will not consider at that situation. But the question is at an instant t after opening the switch. Okay. So they asked you to find out the current after opening the switch. So if the switch is opened, so therefore the current will flow like this. That means 12 volt, 24 volt, okay, 6 ohms and 5 Henry, right? So therefore the question, find the current in the circuit at an instant after opening the switch if a current of 1 amps had been passing through the circuit at the instant of opening. That means here the current of 1 amps is nothing but the I of 0 plus current. Okay, starting initial current is given. I of 0 plus initial current is given. Okay, so therefore, now after opening the switch, the current flow is between 12 volt, 24 volt, 6 ohms and 5 Henry. Okay, so this is the question. Now, so let me solve the question. So that means very simple. So apply KVL for the given circuit. Okay, apply KVL for the given circuit. So if you apply KVL, so therefore that is, so IR plus L into di by dt, okay, is equal to E. So according to the circuit, okay, this is the circuit actually. Okay, so according to this circuit, so I into R plus L into di by dt is equal to E, right? Okay, this is the circuit, right? And also here I of 0 plus is given. Okay, in that question I of 0 plus is given. So therefore I of 0 plus is equal to 1 amps. That means the initial current is given. Okay, initial current is given. Okay, so initial current is given. And in the problem, okay, the R value is given by 6 ohms. Okay, so R value is given by 6 ohms, right? Okay, let me see the question once again. So R value is 6 ohms and the inductor value is 5 Henry, right? Okay, so R value is 6 ohms, okay, and the inductor is 5 Henry, right? Okay, so inductor is 5 Henry. So this is the given question. So therefore now the E is nothing but total voltage. Okay, so total voltage of the circuit. Okay, total voltage of the circuit after opening the switch. Okay, I already discussed after opening the switch. So therefore after opening the switch, what is the total circuit after opening the switch? So therefore what is the total voltage? So let me see the problem once again. Okay, So therefore here 12 volt. So after opening the switch, the current flow between 12 volt, 24 volt, 6 ohms and 5 Henry, right? So therefore the total voltage is nothing but 12 volt plus 24 volt, right? Okay. So therefore, E is equal to, so 12 plus 24, okay, is equal to 36 volt. So this is the E. Now we have to substitute this R, this L and this E in the KVL equation, right? So therefore, so R into I. So therefore, what is your R? 6. So 6 into I, so plus 5 into di by dt is equal to 36. Okay. So now take Laplace on both sides. So as usual, normal procedure we have to follow. So take Laplace on both sides. Okay. So take Laplace on both sides. So therefore, 6 into I of s plus 5 into s into I of s, okay, minus I of 0 plus, okay, is equal to 36 by s. So therefore, 6 into I of s, 6 into I of s, okay, plus 5 into s into I of s, okay, minus I of 0 plus is nothing but what? So there 1 is mentioned, right? So therefore 1 is given in the problem, right? So 1 is equal to 36 by s, right? So if you simplify this, 6 into I of s plus 5 into s into I of s minus 6 is equal to, sorry, not 6, sorry, 5. Okay. So let me correct it. Yeah. So 5 is equal to 36 by s. So now simplify this. So therefore I of s, if you take common, so 5s plus 6, okay, is equal to 36 by s plus 5. Further, if you simplify, I of s is equal to, okay, so 5s plus 36 divided by s into 5s plus 6, okay. So this is your equation. Okay. So this is the I of s equation. Now as usual, the next procedure is we have to take the partial fraction, okay. So take partial fraction. So take partial fraction. So you have to take the partial fraction. So therefore, so I of s is equal to 5s plus 36 divided by s into 5s plus 6, okay, is equal to a divided by s plus b divided by 5s plus 6, okay. So therefore 5s plus 36 is equal to a into 5s plus 6 plus b into s, okay. Now substitute s is equal to 0. So therefore 36 is equal to 6a. Therefore a is equal to 6. So this is the value for a. Now the next one is substitute s is equal to minus 6 divided by 5. So therefore, so 5 into minus 6 divided by 5 plus 36 is equal to b into minus 6 divided by 5. So therefore, so 5 gets cancelled. So 30 is equal to minus 6 divided by 5. So if you simplify this, so 6 minus 6 b into, okay, therefore b is equal to, so after simplification we'll get b is equal to minus 25. So this is A and this is B. So therefore A is equal to 6 and B is equal to minus 25. Now substitute this A and B in this equation. Therefore I of S is equal to 6 divided by S minus 25 divided by 5S plus 6. Okay, right. So now that means what? We can take 6, further we can simplify this. So therefore 6 by S divided by 25 divided by, we can take a 5S common. Okay, so 5 into, right, S plus 6 by 5. Okay, so therefore 6 by S minus 5 divided by S plus 1.2 is the answer, right? Okay, 1.2 is the answer. Okay, this is your I of S. Okay, so now, so this is the I of S. Now what is the final step? So take inverse Laplace on both sides. Take inverse Laplace on both sides. So if you take inverse Laplace on both sides, so therefore I of t is equal to 6 minus 5 into e power minus 1.2 t. So this is the final answer for this problem. So that means that the problem is find the current in the circuit shown in the figure at an instant t after opening the switch if a current of 1 amps had been passing through the circuit at the instant of opening. So for this problem, this is the final solution. Thank you.